Hi, Maddie, how are you? Good afternoon. I'll start in the next few minutes. Were you guys affected this morning when the power and internet went out? Did it go out for y'all too? Yeah. Did your lights go out?
Yeah.
Oh, wow. Scary. Oh. The lights stayed on in here, but like none of the plugs worked and the hallway lights went out. It's very interesting. Maddie, do you live close to the school? Did your power go out this morning? Mm-hmm. Hi, Megan. Good afternoon. How are you? Good afternoon, Michaela and Delaney. Michaela, just to let you know, I've been grading all the quizzes. I don't know, for some reason yours just kept spinning on my screen, so that's why yours isn't graded yet, if you haven't noticed. But I'll get it graded pretty soon. I don't know why it just affected yours and nobody else's. It's very weird. Sometimes I just don't understand Canvas. Okay, 210. Hopefully we'll get some more people coming in soon. I'll go ahead and drop the attendance survey for you here. We have kind of a different class today. Oops. All right. Oh, goodness. Hi, Michaela and Joshua. There we go. All right. There's our attendance survey. Hi, Addie. Good afternoon. I couldn't pick one that I really liked today, so I just put all of the national holidays in for us today so you can see everything that we're supposed to celebrate. If it suits you, this is probably my favorite, the National Deep Dish Pizza Day. I could get on board with that. Or National Caramel Day. Sounds pretty good. For those of you that just joined, I'll drop the attendance survey in here for you. And then our positive thought of the day If you want to change the world, start off by making your bed. This was a quote from Admiral William McRaven, and he was actually the chancellor at UT Austin for a while, admiral in the Navy, many tours, and he actually wrote a book with the name Make Your Bed. And the idea is that if you can complete one small task that can give you the confidence to move to even larger tasks, building your the confidence in yourself. Also, success is not built in one big action, right? Success is built over time as you build knowledge and confidence and abilities and experiences. So know that if you're not in the place that you want to be right now, sometimes it just takes time, knowledge that you need to know, you're going through an experience that you need to go through because you're going to be using it later on. So good advice from Admiral William McRaven. Obviously it helps to make your bed in the morning, but you know, if you don't want to take it that way, you don't have to. And then tell me how you're doing. We had a long weekend. I hope yours was restful. I'm going to drop the attendance survey back in here one more time. Get ready to tell me in the chat. I'm noticing in, well, first of all, I'll start off with this. This week is the last week for grades to be turned in. So this is the last week for the 5th 6 weeks, meaning we're getting closer to summer. We have only 7-ish, 7-8 weeks, I can't remember, weeks until summer vacation, and we're getting back to a little bit of normalcy. Tell me in the chat, because I'm noticing we're getting some assignments in a little bit later. Tell me what's going on. Are we just having a hard time finding motivation? And be honest with me. Are you having a hard time just finding motivation to get it done? Or are you really just struggling with the content and we need to take a little bit more time? Can you tell me in the chat, how are you feeling about the last week or two's assignments? What do you need? Okay, thank you for sharing. Got it. I like that message. I avoid assignments with graphs. Uh-oh, that's not good. Okay, thank you for sharing as far as assignments from other classes. I know if you're signed up for more than one advanced class, it can get pretty overwhelming quickly. So know that, you know, if you need the time, take it, because you don't have a penalty after a week or before a week. However, the longer that it takes you to get it done, the harder it is to continue to understand it and feel like you're on top of things. So going back to Admiral William McRaven, you know, the faster you can get it done, the better. I hear is there an extra credit assignment for the 6 weeks? There's not an extra credit assignment. However, any assignment that you got under a grade that you wanted, you can go back and redo for full credit. So I know the matching assignment, several of you, I circled the ones for you to go back and redo. The one with the transformations, if you want to go back and redo that. The quiz, I may open that up on Friday, Thursday and Friday for you guys to redo if you have any interest in redoing your quiz. Because I know that there was some switches and transformations, especially with the logarithmic functions. For example, I'm going to show you this because this is one that I noticed quite a bit. In your quiz, we had something that looked like this. Log base 2 of, I don't remember, x minus 2. And you guys put that this shifted right 2 spaces, except look at the difference. This is very different from this, okay? This in the parentheses signifies a horizontal shift. And this outside the parentheses signifies a vertical shift. And so several of you mistook this as a horizontal shift, and that's why you didn't get that point for that one. So I will open up the quiz again for you to redo, because I know you guys can do better, especially with the transformation. Sometimes they're just a little bit confusing. Yes, right. So hopefully that answered your question, Joshua. I'm going to post the attendance survey one more time. So here's FYI for this week, okay? Write this down, take a picture, whatever you need. All right, so we have notes today. We're going to finish our notes on logarithmic applications today. Notes on 4-5. Here's the other thing, your test. We have a test this week. It opens today, so it's already open for you, and it's going to close on Thursday. We're going to go over it today in class. This is the last assignment. Good question. I was asked how many more assignments do we have? This is the last assignment. The test is the only thing that we have this week. But I'm going to give you 4 days to do it, because you're going to want to take time on it. There's 4 parts. We'll go over it in a little bit. And it has to do with the notes that we're taking today. And then on Wednesday, we have no live class, because I want you to finish your test. I will have Zoom open. Zoom will be open. So there's no live class. You're going to finish your test. I'll have Zoom open if you want to get on and ask any questions. That'll be available to you. And then on Friday, the school or the district wants us to give everybody like a catch-up day. So Friday is our catch-up day. Not tomato ketchup day. Just catch-up day. So if you're caught up, then perfect. You have a free day on Friday. If you're not caught up, that's your day to get all your missing work done. I will finalize grades at 3 o'clock on Friday. I don't wait until Monday. So if you have any missing assignments, please make sure that it's to me by Friday. Many of you are okay. Some of you are teetering that line. So whatever you are wanting for your grade, this week is your opportunity. The test does close on Thursday at 11:59. And that's because I wanted to give you and B-Day the equal amount of time. So you have 4 days and B-Day has 4 days. You'll get it. It's only 4 questions. I promise you'll get through it. Okay, let's look at our notes for today. We had some, let me make this larger. Any other questions about this week? Okay, all right, so we talked about what the natural log is, and we are starting to solve logarithmic equations. We solved these together, A, B, and C, in our notes. We're going to go over these now. You try. So we'll do this together, and so check your work as we go. So I'm going to do A. I'm going to do A, and then I'm going to ask you in the chat to do the other ones, or tell me what you got for the other ones. So we talked about if you see our E as a base, you can take the natural log of each side. Remember, natural log is the same as log base E. So taking log base E of E pretty much cancels that out. And we proved that algebraically in our notes. So ln of E to the 3k power equals ln of 60. These cancel here, so 3k equals ln of 60. And we're going to go ahead and solve for k by dividing by 3. Go ahead and use your Desmos here. Function ln of 60. Don't forget to close your parentheses here. Divided by 3. And our answer is 1.365. So that's your answer for Okay, all right, let's look at B. Go ahead and work on that one. Tell me what you get in the chat. We're on B now. Thank you. I see some responses already. I'm working it out here on the side if you're not quite sure yet, if you need help getting started. Okay, thank you. Looks good. Did you guys close your parentheses? Try that again. All right. If you are not done or you are just completely lost, put a question mark or not done. So good. I'm seeing good answers there. Yeah, either put your, okay, thank you. Question mark is okay. That means I know you're still there. Make sure that when you are calculating that you are closing your parentheses. Okay, so here we are. I've worked it out. We have e to the v plus 7 power minus 10. We want to isolate our e first by adding 10 to both sides. So we have e to the v plus 7 equals 68. We took the natural log of both sides. When we take the natural log of e, it cancels and brings that exponent down. So we have v plus 7 equals the natural log of 68. I'm going to solve for b by subtracting 7. So I have v equals the natural log of 68, natural log of 68. And notice you're going to get a different answer if you don't close your parentheses. So make sure that you're closing your parentheses. I don't want to find the natural log of 68 minus 7. I want to find the natural log of 68 and then subtract 7. So we should get a negative 2.78 there. All right, let's try the next one. Let's try this letter C. I'm not sure where I'm going to work it up here. So I have a negative e to the x plus 9 plus 2 equals 35. Yeah, so Jake asks, is this on the test as well? This is a big part of the test, doing this part, or a small part. We're going to do it in just a second. All right, so I'm going to solve for that e by subtracting 2. So I have a negative e to the x plus 9 equals 33. And see, we have a negative here, so I'm going to get rid of that. So we have e to the x plus 9 equals negative 33. Take the natural log of both sides. So we have x plus 9 equals natural log of negative 33, and then subtract 9. So let's see what this is. I should have done it in my journal. It's getting kind of messy.
0.
Huh?
0.
0?
Or undefined.
Mm-hmm. Yeah, so it can kind of tell you here a natural log of a negative number is undefined. Why is that? Okay, so in our notes, you can copy that down. In our notes, we talked about Newton's law of cooling. Newton's law of cooling is uses our constant number E here, or Euler's number. We did the first example together with the cup of coffee. If you haven't watched the notes yet, I would really suggest going back to watch those notes first before starting the test. But we're going to do the second example together. And this is going to be a lot like your test. Okay, that's why I wanted to do it with you. Okay, I should probably get my notebook out. If you don't have your math journal out, I would suggest getting it out because you're going to want to know this. Or a piece of paper or whatever. All right, so we have a situation here. At 8:30 a.m., a coroner was called to the home of a person who had died during the night. To estimate the time of death, the coroner took the person's body temperature twice. At 9 a.m., the temperature was 85.7 degrees Fahrenheit, and at 9:30 a.m., the temperature was 82.8 degrees Fahrenheit. The room temperature was 70 degrees Fahrenheit. When did the person die? So here's our steps below. It'll help us as we go through and solve the equation or the function. Notice when we took our notes the first time, we have to find that constant rate of cooling first. Sorry, it's blurry. We have to find that constant rate of cooling first and then use our new function to find how much time will pass. So we're going to do the same thing, and what we learned was that it was going to take 11 minutes for it to cool down to 155 degrees. We're going to do the same thing, except we're going to work a little bit backwards, okay? All right, so let's talk about things that we know, right? I'm going to write down Newton's law of cooling. By the way, this is what coroners use to find out time of death. So we have T of T equals the starting temperature or the surrounding temperature, the initial temperature minus the surrounding temperature times our constant E to the negative K, which is our cooling constant or our decay constant, times T time, okay, time elapsed. So what do we know from our situation here? We know that the coroner went to the house at 8:30, right? So he took two temperatures. He took a temperature at 9 o'clock and it was 85.7 degrees. He took another temperature at 9:30 and it was 82.8 degrees. The other thing that we need to know is that the surrounding temperature or the room temperature was 70 degrees. Okay, so let's start labeling what we know, right? Pull out my. If you have questions as we go along, please just put them in the chat and I'll answer as we go. So our T of S is that 70 degrees, right? So T of S is 70 degrees. It's our surrounding temperature. And then our initial temperature, we're going to start here, 85.7. And then we want to think about our time elapsed, right? So we're going to think about this in hours. You could do minutes if you wanted to. It's really up to you. I would suggest doing, well, it really doesn't matter. I would suggest doing hours. So our time elapsed here, this initial time elapsed is 0.5, right? It's half an hour. You would get the same time if you used minutes. And let's see, what do we not know? We don't know our cooling decay constant here, but we do know that at that half an hour, T of 0.5, it was 82.8, right? So think about this. You can't solve an equation with more than one variable. You need to narrow it down to just finding one variable. That's exactly what we've done. We've identified 4 variables, and now we're just looking for that decay constant. So let's plug everything in. We have 82.8 equals 70 plus the initial temperature, which is 85.7, minus 70 times E to the negative K times 0.5. All right, now we're just going to narrow it down to maybe look like the equations that we were solving on the first page. So let's do 82.8 minus 70. We get 12.8 here equals 85.7 minus 70, which is 15.7 E to the negative, I'm going to switch these around a little bit, to the negative 0.5 K. All right, next step, I'm going to isolate that E value by dividing by 15.7. I'm going to leave it like that. So I have 12.8 divided by 15.7 equals E to the negative 0.5 K. This is where we bring in our natural log, right? Whenever I have E to a power, I can eliminate that E by taking the natural log of both sides, right? So I'm going to say ln of 12.8 divided by 15.7 equals ln of E to the negative 0.5 K. That cancels our natural log of E there. So I have ln of 12.7 or 12.5 divided by 15.7 equals negative 0.5 K, and we'll divide by that negative 0.5 to find K. So let's see. Natural log 12.5 divided by 15.7. Close your parentheses, divided by negative 0.5. And our cooling constant, or decay constant, is 0.456. 0.456. We'll use that number. But that's not my question, is it? The question is, when did the guy die? Well, this 0.456 doesn't help us at all. So what we need to do is take this value. It's kind of like when you're given X, I don't know. Thank you, Maddie. It shouldn't have. Y'all keep me in check. This should be 12.8. It's just because let's see. Let's see how it changes. Oh, 4.0. Thank you, Maddie. 0.408. How's that? All right. Thank you for watching that closely. Otherwise, all the numbers will change at some point. Okay, so here we go. Let's rewrite this in a function. You guys remember way back in Algebra 1 where you had to find your slope, and then you had to plug your slope back in and the point to find your equation of line. This is the same thing, okay? It's not anything different. It's just you're using a different kind of formula. All right, so let's see what this says. This is T of T equals 70, right? Plus that initial temperature of 85.7 minus 70 E, and now our cooling temperature, or our cooling rate, sorry, like that. So this is our equation that we can find out at any point in time what the temperature of the body is going to be. So we could even plug this in and find out when the temperature of the body is going to be at room temperature, right? So you can use this to work backwards to find out when the man actually died, or the person. We don't know if it was a man or a woman, do we? So tell me, because I need to know, first of all, what temperature a person is before they die. It's kind of morbid, but tell me in the chat, what is a typical body temperature? Yeah, 98.6, right. So I want to know, when was this man's body, or this man or woman's body temperature at 98.6? Let's find out. This will be very interesting. So we're going to plug that in. 98.6 equals 70 plus 85.7 minus 70, 0.408 T. All right, so we're going to go about it the same way that we did up here, right? Taking the natural log of both sides and finding time. Here's the, oh, it's supposed to be negative, right? Because it's negative K. Here's the kicker. If he was 85.7 degrees at 9 o'clock, what do you think my T value is going to be? Just take a wild guess. Go ahead and put it in the chat. What is your guess? What do you think the T value is going to be? It's not gonna, I'm not gonna get an answer of 7:15, right? I'm gonna get, what am I gonna get? It is time. So some of you are putting in numbers like 5. If I got a T value of 5, that means that my time would be 5 hours from 9 o'clock or since 9 o'clock. So that would mean it would be 10, 11, 12, 1, 2 o'clock, right? So what kind of T value am I going to get? Yes. I love the exclamation point. Yes, you are going to get a negative number because you're counting backwards from 9 o'clock, right? Or I should do it this way because you're looking at it that way. We're going to be counting backwards from 9 o'clock. So you're looking for a negative number. If you don't get a negative number, then you probably need to do something different. All right, so let's go back to our math. We're going to simplify all of this here. So we have 98.6 minus 70, which is 28.6 here, equals 85.7 minus 70, 15.7 E, negative 0.408 T, divide by 15.7. So I have the natural log, I'm moving a little bit quickly here. 15.7 equals the natural log of E to the negative 0.408 T. Those cancel. I have natural log of 28.6 divided by 15.7 equals negative 0.408 T divided by negative 0.408. And let's see what our T is. All right, so we have a negative 1.47 as our T value. So, yes, Jake, we're gonna go over it in just a second, I promise. All right, so that means that this person died an hour, 1.47 hours before 9 o'clock. So can you tell me what that is in hours and minutes? Tell me to the nearest minute what time this person passed. Try again, Joshua. You're really, really close. You guys are almost right on the money. Eduardo, Jamie, Lorelai, Maddie, Megan, what do you guys think? You guys are so close. All right, let's think about this because it's minus, right? Minus 1 hour. So if my initial time was 9 o'clock, right? So I'm starting at 9 o'clock. I'm subtracting 1 hour, right? That gets me at 8 o'clock. Then I'm subtracting this 0.47. So I want to know how much of an hour is 0.47. It's 28.2 minutes, but it's not 28.2 minutes after 7 o'clock or after 8 o'clock. It's 28.2 minutes before 8 o'clock. So what is that number, 28.2 minutes before 8 o'clock? Yeah. So our approximate time of passing, is 7:32. Whew, take a big breath there. If your head is hurting, that's okay. Give yourself a pat on the back because that was quite a whirlwind. I like this. Poor fella died at 7:32. Yes, that's true. Poor guy. So our test is going to be there's one question that's exactly this, okay? So I don't want you to get confused. It is what we've been talking about. So don't think you can't do it. You can do it. And let's look at it right now because I know we're running out of time and you guys have to go to practice and stuff. There has been a murder, a shipwreck and a murder. You and several travelers have been shipwrecked on a tropical island. It's a beautiful place, except there was one of the travelers, John Doe, has been murdered while you guys were shipwrecked there. There's no one else on the island but you and these other travelers. FYI, you are not a suspect, so don't put yourself as a suspect. And you're given several different types of temperature, okay? The temperature on the island and then different body temperatures after a period of time, okay? There are 4 questions and each question is 4 parts, okay? So some of these questions you will have to upload graphs. One of the questions is looking at a hot cup of coffee and how it cools off, which we have talked about in our notes. You can also do your own experiment at home. If you guys do that, I would love to see it with a cooking thermometer. And then posting your graph there. So that's part of the first question here. The second question is actually doing some of the numbers that are given. So the first one is kind of hypothesis, right? And the second question is putting some numbers that are given in the question into a graph, and then talking about other functions that we've talked about in class. Hint, hint, logarithmic and exponential. The third question there talks about Newton's law of cooling, which we've discussed today. And then just questions about this, okay? The fourth question is actually going through, or this one was, you're finding the dk constant, that k value, and then you're uploading a picture of the graph. The fourth question is actually answering what was the time of death, and then here are your suspects here, and what suspect would you, or what 4 suspects would you say are your suspects, okay? So there's 4 questions total there. If you would like to work with other people, that is always an option. This is not something that you have to do by yourself. Although if you want to do it by yourself, that's totally fine. If you would like to do this with your parents, if you would like to do this with a sibling or a friend, please feel free to do that. This is not going to be you sitting down and getting this done in an hour. This is going to take time. That's why I'm giving you 4 days, okay? So are there any questions about this test coming up? It does not have a time limit. Delaney asked a good question. Does it have a time limit? It does not have a time limit. You can go in, do some of the work, save it, right? It saves automatically. Sam was testing it earlier, and you can go back in and resume it. So it does not have a time limit. Great question. I guess I'm glad, Joshua. That's good. I wish we were all together and we could do this together, but that's okay. This is a good opportunity. If you do like working by yourself, then you can work by yourself. If you want to work with other people, please feel free to do that. I am excited to see what you're going to come up with. It is 4 questions and 4 questions each, so 16 questions total. None of these people are you. None of you are suspects. So please know that. They're all random names that I came up with, and I hope that you have a good time with it. On Wednesday, I know we're getting short on time, but on Wednesday, I will have the Zoom open if you have any questions. Please go back and look through the notes. I think that I recorded today's class, so I'll post that in Zoom too if you want to look back at the time of death one that we did together, okay? All right, so if you don't have any other questions, I'm gonna let you go, and this is due on Thursday, so I will see you soon. Oh, lastly, sorry, if you're coming to class next week, I know next week on the 13th is optional to be coming in person. I'm going to change things up a little bit. Those who are here and those who decide to come, we're going to do live instruction at the first part of the class time. So we will do actual math together, and then Zoom will still stay at 2:10 for us. Okay. All right. So if you're coming next week, I'm excited to see you. If I see you on Zoom, then I'm excited to see you there, and have a great week. Bye. Bye, Maddie.